Good morning, one and all. My name is K. Rishikar Reddy, respected sir, ma'am. I am from IARE College, ECC section, and today my topic is about Laplace transformation, LT, partial fraction, expansion. Here we go in the introduction. The introduction is about the Laplace transformation. The Laplace transformation is a PowerPoint integration transformation. It is used in two types of variation times domain function into a complex fraction, frequency, domination, and function. Here is a picture given, and the picture itself say that L of x t by equals to f s brackets time domain representation of system. It is denoted by the picture itself says that it is very complicated physics of mathematics to simple the analysis of linear time invariant systems. The transformation is declared by the transfer complex numbers. And here is the introduction is about the complexity of frequency domain. In the frequency there are two types of frequencies. That frequency are required in the picture given itself. And when coming to the next one, properties of land transformation. Here is a picture that says that the table of pairs, what are the properties and what are the definitions of each and everything. And the significance properties of land transformation is literally which is allows the transformation of linear combination functions. That second has property in the time situations. Sir, here we have the time situations where time parallelly shows that Boolean method and timetable of the transform cities. T is the ratio of time approaches and the infinity is green property, whereas the green property has also tabular form like d by dx of tan d by ax, and the properties of the table is linear combinations of functions. And the second property is time shifting, which states that linear transformation of time additional is international value theorems provide insufficient into a behavior of systems. Here is the properties of land transformation transforms. In the land transforms, green signals and green city is green significance also is a main approaches in infinity. We're coming to next one, inverse landform place. In the inverse landform place, here is a picture that given in 36 properties, but if we zoom it properly we can observe the properties and the formulas of the time, whereas the formulas and the time are same denotatedly and probably domain back to the days. It often completed using complex conductor integration of a reduced theorem. Here is a theorem given. The theorem has many properties and invalidation of notation and transformation is given by the LT formula. Here is the LT formula, sir, where LT formula is also applied by the frequency domain back to the time. Time also represents the with suitable formulas. With that suitable formulas we need to apply the frequency and the notation, inverse and transversal properties. And the transversal property is also denoted as many sign significance. In this significance we can also observe the inverse properties of the given time. Coming to the next one, application of land transformation. Here is a picture, sir. In this picture, d by dt is the formula based on this chapter, and the circuit theorem chapter undergoes in the differential properties, whereas L equals to f of x by f of tx, L equals to t by dt, f of t equals to f of s minus f of naught by f of t, L equals to dt by dx by r square in inverse of property, whereas the properties are gained into two types. They two types are L1, L2, L3. In this three L's, main the dt course is must and should, f of t is second and f of tx is third. Laplace transformation means, here is the introduction, sir. I am going to read it. Here is a land transformation theory for analyzing and designing linear control systems. They are also applied in solving differential equations. Particularly in engineering, in physics concept, there are must used by this, by acknowledging and by transforming differential equations into algebraic expressions. Equally, the simplicity, the functions of the properties, and the process of including finding solutions. And the chapter 13 itself says that LGR 273 circuit theory, and the circuit theory is founded by making the time differential properties of Laplace transformation recalling. Coming to next one, sir. Introduction of partial fraction expansion. Here is a introduction of partial fraction in differential, sir, where we can observe the partial fraction expansion in different ways. There are two types of methods given in the formulae on formulae V. Form of rational function, form of partial fraction, f of x plus q by x minus a equals to a alpha b and a by x minus b is a minus x a k. Here are the two formulas. C cannot be used in partially fractions and equations. Partial fraction expansion is a technical used by the formulas break down rational functions into simple fraction. This method is particularly useful in the content of inverse Laplace transformation by decompressing a fraction into a partial fraction. The inverse transformation can be found more easily. Coming to the next one, sir, steps. Here are the main steps, sir. Steps for partial fraction expansion. The first step is involves an expression of rational function in proper form, ensuring the degree of the numerator is less than the function denominator. Next, the function denominator is used as next, identification of factors in domain, whereas the domain function expresses the sum of fractions with unknown certificates. And the final solution is certificates by equating coefficients or suitabling confident values for the variable. Coming to next one, sir, examples, sir. Examples of partial fraction expansion. Here is a two table, and the conditions are considered by the rational functions. Differentiating as an example of partial fraction expansion, we can express it as f of x by a and solve for constant a and b. After finding a and b slash and b slash, the fraction functions can be denoted individually. Here is the individually property, sir, where we can denote as two major points, and the two major points are form of the fractional function, form of the fractional partial. Here is the main theory is f of x plus bx plus c are partially fraction furtherly. Coming to the conclusion, sir, I have concluded that in both the in three L3s there are must and should used by the d by dt is a formula, whereas b and dt formula never leaves the partially fraction, sorry. Mastery of these concepts is critically for engineering students and the professional works in controlling the system signal processing. Yes, a system signal processing is must and should because of these outlines fractionally we need to conclude by this. And the summary is faculties and other engineering students can also be used by these partially differential properties to explain the and to control and to work with the systems of signals and process. Thank you, sir. Thank you for giving me this opportunity.